I used to think that electrons orbited the nucleus, something like this. But then I asked myself, if electrons produce an overall negative charge, while the nucleus produces an overall positive charge, and they both create electromagnetic attractive forces, why doesn't the electron just collapse into the nucleus? Well, it turns out electrons actually move more like this. Actually, more like this? Why does this happen? Now, let's first take a look at Heisenberg's uncertainty principle. That looks obnoxious, but let me simplify it for you. Now, look at this illustration of a baseball. If I were to ask you to tell me exactly what position it is on your screen, you will be able to give me a definite answer. But if I were to ask you, where is this ball going, you wouldn't be able to tell me anything from this information. Now, let's look at this photo. Great! Now you can tell me where it's going. But if I were to ask you, where is the ball currently, you wouldn't be able to tell me anything from this information. This is a fundamental concept we need to grasp in understanding the movement of electrons. The more you know about an electron's momentum, the less you know about an electron's position. And the more you know about an electron's position, the less you know about an electron's momentum. Let's try another thought experiment. Schrodinger's cat in the box. This thought experiment requires you to imagine, well, a cat in a box. Now let's say you close this box. How would you be able to know whether the cat is awake or asleep? The thing is that you won't know. So in other words, the cat can be described as being in both states, asleep and awake, simultaneously. The cat is in the superposition between being asleep and being awake. This same concept can be applied to electrons. Electrons exist as superpositions of multiple positions until they're measured. This uncertainty creates a field of probable positions of the electrons called a wave function. This wave function will look something like a cloud around the nucleus. Now, let's return to our original question. Why doesn't the electron just collapse into the nucleus? Because of quantum mechanics, electrons exist as spread out wave functions, which are superpositions of many positions, meaning that an electron cannot be localized and confined to a single point. Now you might be asking, how can any of this be applied into real-life innovation? Well, 2 words: quantum computing. Classical computing uses binary or bits to translate data. There are 2 possible states of a bit, a 1 and a 0. Quantum computing uses a similar concept. They're called qubits. But what if a bit could be both 1 and 0 simultaneously? Right now, I have a coin. If I were to say that this heads represents a 1, while the tails represents a 0, and if I threw it into the air and caught it with my hand, this coin would be in a superposition between 1 and 0. Now, imagine if I were to repeat that 1,000 times to write a line of code. I'd have 2 to the exponent of 1,000 lines of code that could be written. That's 1 followed by 300 zeros. And that's the beauty of quantum computing. It can make calculations that seemed impossible just a few years ago possible today.